Hello and welcome to my channel, Linux World. In today's video, we are going to talk about managing hard disks on the Linux system with the parted utility and fdisk. In the last video, we have discussed how to use fdisk to partition the disk, how to identify disks on the system, and such and so forth. And today we will learn about another utility called parted. Let's get started. So let's first to check how many disks we have on the system. I'm going to run a command ls blk -d. We have two disks, SDA, STB, and a CD-ROM. Let me just run ls blk by itself. Seems like STB is in use and it has two mount points. Okay, it's mounted on app1 and app2. I can run df -th command and see that it is indeed mounted. Okay, so we will add another disk and we will talk about parted utility. So the difference between using fdisk to partition your disks and parted, the primary difference is in Linux, their functionality and support for different partitioning schemes. Both the tools are used to manage disk partitions, but they have distinct features and limitations. So fdisk is a traditional command line utility used to create, delete, and manage partitions on the disk. Primary works with master boot record, also known as, in short, MBR partition tables. So if we look at fdisk -l/dev/sda, that's our first disk. You can see that the disk label it's called DOS. It's used for MBR records. So master boot record is there for the system to boot up. Okay. Though it supports GPT type partitions in modern versions of fdisk. So I am assuming since we are on a system, RHEL 9 system, the fdisk utility is new, and it may also support to create partitions, GPT partitions, which stands for GUID Partition Table. Okay, there's benefits of using that. First of all, with the fdisk, when you create partitions, by default it is type DOS. It only allows us to create 4 partitions. So if you give it one disk, it'll be SDA1, SDA2, SDA3, and SDA4. So you can create 4 partitions. With GPT type of label, if you label it like with GPT, you can create up to 120 some partitions. Okay, we'll look at that in action. So more about parted. So if I run, first of all, let's check if we have parted. And which command or command -v will show you that we do have parted utility. It's a more modern command line utility for creating and managing partitions, including working with larger disk size, designed to work with both MBR and GPT partition schemes, and supports larger disks greater than 2 terabytes. Okay, which requires GPT labels. Okay, so if you have hard disks coming more than 2 terabytes, you might want to partition them. If you're partitioning them, might want to label them with a parted utility. So we will look at that on how to do that. Okay, and yeah, parted also supports advanced features like resizing partitions and creating file systems during partitioning. Okay, stuff like that. So with that being said, we know that we have 2 disks. I'm going to assign another disk to the system, a 3rd disk, and we will then use that to test our partitioning with parted utility. So I'm going to log into my vCenter here. Okay. Okay. So I am logged into VM37 here, so I will go to VM37. I'm gonna go add another disk. I can reuse the disk. I don't want to cause any confusions right now. The best practice is to assign a new disk to work. Add a device. It's going to be a hard disk. This is going to be another 10 gigs. And okay. And we should see it right away now. If I rerun the command, now we have SDC. So they're alphabetical. We talked about this. So I can run SCSCSI as well. You can see a different output. Okay, let's clear the screen out. Usually I just run this so I see the whole topology. So SDC is here at the bottom. So if I run fdisk -l/dev SDC, it does not have any disk label assigned to it. It just gives you information about the model and stuff. So we're going to use parted utility to first label the disk with the command. If you run parted by itself, you go in this interactive mode where you can type in help and you can see all the help. To make a label, you can see that there are commands right here. We could, just like the fdisk utility, you can use it in an interactive way. I'm going to quit. I'm just going to use it. We also have an option to use it as a script on the command prompt, so we're going to go ahead and use that way. Parted -- script, and we're going to be working with dev SDC. Okay, and in quotations, we're going to specify mk label GPT. Okay, we're going to label this disk with GPT type partition, which is which allows us to create about 120 partitions. It also works with larger disk sizes, over 2 terabytes, right? So we know that. And GUID Partition Table, that's what it stands for. Press enter. Must have made a mistake with the command. Okay, so let's check the command here. Control C, clear the screen out. Bring the command back and let's see what I did wrong. Okay. parted -- script /dev /SDC mk label. I think I spelled label wrong. GPT. And there you go. Now we do parted -l. We'll list out all the disks on the system. I ran the command here. Okay, so the first one is SDA. We wanna, which is partition type is MS-DOS type, which is the master boot record type, pretty much. The SDB is type GPT as well as our SDC here. SDB is here, type MS-DOS, which we created 2 partitions yesterday. The first one we created XFS file system, and the second one we formatted for ext4. We could see that here. And the third one that we did today is SDC, which you can see here. It's type GPT. I think you can run parted -l/dev /SDC. And it still gives you the whole information, but anyway, so SDC is with GPT. Also, you can run fdisk -l on that /SDC. Will also give you information about this disk label. Okay, so now if I use the fdisk utility to go inside the disk like we saw in the last video, to make more partitions, and for help to create a new partition is to press N. If I press N, Now you can see here, you can create from 1 to 128 partitions. Okay, I'm gonna Control C to get out of there, but this is what the GPT label type gives you. Okay. Another thing I want to show you is, let's see if we can do this disk label with this disk label with the fdisk utility, since we can do that with the modern fdisk utility. So first thing we want to do is clear this label up that we created. -L, this label that we created, and then try to create it with fdisk. Okay, so to do that, we want to delete the label first. So to delete the label, we want to use which SG disk utility is there. SG disk -zap -all, like that, def SDC. So it will clear that out. GPT data structures destroyed. You may now partition the disk using fdisk or other utilities. So let's clear the screen out, or learn fdisk -L. I'm gonna make this bigger a little bit. Okay. /dem SDC. Now it does not have a type here. If we go up here, we ran the command, it had a disk label assigned to it. Now it does not. So we can now use fdisk utility and go inside the disk, SDC, and M for help. Oh, here at the bottom, you see you can create a label. And to create a GPT type label, you just type G and enter. And it says created a new GPT label with the GUID. So I want to just print my changes, and it shows that it is, in fact, GPT label. And I want to write my changes with W and get out of there. Okay, so fdisk -L/SD dev/SDC, we have labeled our disk using parted utility and cleared it, deleted that partition label and with the SG disk utility, and then created this label with fdisk. Now, I mean, we have parted available if you want to use parted. I personally have been using fdisk, so I will stick with fdisk to create disk partitions. Sometimes you might not even need to partition the disk, but if you need to, you have, let's say you have been given allocated a large disk, if this especially on physical servers, when the disk is coming from SAN, and they might give you a 5 terabyte disk, and you might need to use it for different purposes. You can then partition it, and especially with GPT, you can carve out how much you need. So let's just, this disk is 10 gigs. Let's pretend that this is about 10 terabytes, okay? Let's think that it's 10 terabytes, okay? So let's go use the fdisk utility to partition this disk. Disk. You can use FD and then press DI and press tab. It will do the tab completion for you. Dev SDC, let's go inside that disk. And then we're going to create a new partition. Now you can see that you can create up to 128 partitions. So we can obviously work with large disks. So I'm going to use the default one, first partition, default sector. The starting point is good. Here I'm going to specify the size. I'm just going to partition 1 gig. Out of the 10 gigs, I'm going to take 1 gig. Okay. Or 10 terabytes, I'm going to take 1 terabyte. Let's just pretend. Basically, I'm trying to make is 10 partitions. Okay. And then I'm going to print. That looks good. 1 gig right here. I'm going to write the changes. And I'm going to do again another partition, new. This is going to be second partition. This is going to start here plus 1 gig, write my changes, another partition, new, third, plus 1 gig, print third partition 1113, write my changes. Let's make another new fourth, this plus 1 gig, print, right. So we have already created 4. Let's create a 5th one just to exceed our limitations on MBR partition, DOS partition. New, default 5 is fine, starting point is fine, ending point plus 1 gig, and this is just the starting sector where on the disk it's going to start, and the end point we're specifying that stop after 1 gig. We talked about this in the video of learning and managing disks on the Linux system, my previous video, and learning the fdisk utility. And I'm going to print and write changes. So clear the screen out. fdisk fdi -l/dev/sdc will show us that now we have 5 partitions. So think of this as 5 disks. We have given 10 terabytes. Let's imagine it's 10 terabytes, and we have created 5 disks, 1 terabyte each, out of this one disk, right? We carved out and we made 5 disks. And if you want, if you wish, you can lay, like we saw in my last video, you can do mkfs. Any disk you want to use, you have to lay down a file system on it. It's a raw disk. So mkfs minus type xfs on /dev/sdc1. Okay. And then ls/ I'm going to create a new directory called mkdir/my app or my db 01. And I'm going to mount /dev/sdc1 on my db01. Oh, sdc1, sorry. Okay, so lsbok will show me that LSDC disk is about 10 gigs, and it has 5 partitions, out of which the first one seems to be mounted here, so it's in use. Okay, and now we can make it permanent. We go etcfs tab, we go down, dev sdc1, it's mounted on /db1, I think so. Type xfs, file system type, we stick with defaults, and defaults here as well. Let me just make sure that, oh, it was my db01, so let me just go back in here. Let me change this my db01, right? Insert my db01, that looks good. Just to run mount -a to mount all the file systems, no error. And you have app1, my db01, everything, lsbok, another view. Yeah, it looks good. So we can do similarly, we can use all these disks. So partitioning a disk could come in handy, especially the GPT type partition label. When you're working with larger disks and you want to carve out disks, you can get up to 128 partitions and use it like so. Okay, right, in the next video, so far we have discussed how to list the disks, identify the disks, partition the disk with fdisk or parted. We have made a disk, learn about the different type of disk labels, and using the parted utility and fdisk utility to partition the disks. Okay, in the next video we will talk about logical volume management and how to use it with the fdisk utility. And thank you for watching. Stay tuned.